In this video, I will go deeper in some details about how to combat arterial stiffness and waste accumulation in our bodies. These two factors, I believe, the main causes of aging, main causes that we live so short. Potentially, we can live forever young, but not 120 years, not 80 years, or we can live much longer. And let's go to details what we can do. So I hope you download this presentation as PDF file from the description, from the link in the description, and also you can go to the references, to the sources of information, and make your own research. And I hope also you watched my previous introduction video about this, so it is without references, without links to scientific publications. Now I will go more in details. Okay, so let's go. So in my opinion, aging is mostly caused by two processes, the main causes. Okay, this we have to put our attention to this process, how to reverse them. So, number one is stiffening of tissues and accumulation of waste substances. Stiffening of tissues is one, and second, it is accumulation of waste substances inside and outside cells. Dietary choices and intermittent fasting can slow down the accumulation of waste substances, while autophagy, the self-cleaning process of cells, removes waste inside the cells. Okay, I was going in many details what we have to avoid for example, to reduce accumulation of oxalates, etc., etc. So, and so I will make references, but you can also invite it to watch my other videos. Our immune system is supposed to remove waste outside the cells and improve tissue elasticity. However, our body does not produce all necessary enzymes to degrade all waste and harmful substances in lysosomes of the immune cells. So even if immune cells will remove this substance, it cannot digest it, it cannot split it to nutrients, and then it is just accumulating inside, and these immune cells eventually die. So Dr. Aubrey de Grey proposed enhancing lysosomal function by introducing exogenous enzymes, bacterial enzymes actually, to degrade waste substances. And in publications, this you can go to and read it. I use this idea. This is, I think, a very interesting idea. He expressed it in 2002, but since then there was not much progress in it. Okay, so. Again, you can go to the references, read it, because I believe it is very important. So this is a strategy to slow down or reverse aging and age-related diseases. Okay, this is, again, the way I go. I have discussed this idea and my proposals for developing advanced enzymes in several presentations. You can go to read this presentation, download as PDF file and read. And also you can watch videos. See 4 videos. Cell migration is essential for homeostasis of multicellular organism. Indeed. So what our immune cells have to migrate through our body and kill some hyperactive cells or infected cells and remove waste products, waste substances from extracellular matrix, from the outside of the cells. But if it is stiff, extracellular matrix is stiff, they cannot migrate. Also, many other cells have to migrate, including stem cells. Stem cells are supposed to replace damaged or all the cells, and they provide maintenance. So over time, migration of fibroblasts, keratocytes, immune cells and stem cells is getting compromised because of stiffening of tissues. They just cannot go through, because if it is elastic, then cells can get through this extracellular matrix, but if it is not elastic, it is just compromised. Also, stiffening of the blood vessels leads to a chain of processes that accelerate aging, including inadequate oxygenation and the development of chronic hypoxia. This is a shortage of oxygen in tissues, hypertension, accumulation of senescent cells, chronic inflammation, excessive deposition of collagen fibers, so-called fibrosis, accelerated accumulation of metabolic toxins and waste, immunosenescence, self-intoxication with pro-inflammatory molecules and waste products, and ultimately death. So you can go and to references to source of information, or if you don't understand some words, what I use, then click on in these links in the text, and you can get to Wikipedia. Mostly I use Wikipedia to explain the meaning of these words. Okay, so this is just a short picture. So in young vessels are very elastic, and so the very elastic. Our blood pressure in young age is normal, so-called normal. Yeah, but as we are aging, we develop mostly hypertension, and because of the hypoxia, that we have a cascade of process which is going, and what we have chronic accumulation of senescent cells, chronic inflammation, oxidative stress, etc., eventually death. So here we can use some senolytics, because if you start this age reversing proposals, which I cite here, then mostly you started in older age and you have already senescent cells. It's better to remove them with senolytics, especially special drugs to remove the senescent cells. It will help. Well, okay, so age-related deterioration in the cardiovascular system includes cardiac hypertrophy, because heart has to grow bigger to pump blood through your system. It is the stress on your heart is increasing because the stiffening of the arteries and stiffening of the blood vessels. So next is dysfunction of diastolic dysfunction, and it is our kidney don't work. Myocardial fibrosis, it is again stiffening of the heart, and arterial stiffness, and the cilium dysfunction also. Our blood vessels become do not respond to signals of the to improve the blood flow, and a decline in nitric oxide bioavailability, because if your endothelium is damaged, it cannot produce nitric oxide, and then you have a shortage of oxygen in your tissues. These changes are driven by interconnected processes such as chronic hypoxia, mitochondrial dysfunction, oxidative stress, dysregulated autophagy, chronic inflammation, fibrosis, and senescence. Again, this is a chain of process which start from stiffening of the blood vessels, and it is goes and develop further, and so you can read the scientific publication. Targeting the fundamental mechanism of cardiovascular aging with interventions such as aerobic exercise, supplements, and selected pharmacological drugs represent a promising approach. Okay, this is just scientific fact, and I use it. In this presentation, I will dive deeper in the stiffening of blood vessels and propose some pharmaceutical drugs that could potentially slow down cardiovascular aging and extend longevity. Okay, so what we have, that because of stiffening of blood vessels, cardiovascular risk increases. So, and we have all these age-related diseases. Cardiovascular disease is a leading cause of human mortality, including conditions such as stroke, heart attack, and heart failure. Vascular aging plays a significant role in progressive dysfunction of organs throughout the body, eventually leading to death. Arteriosclerosis, which causes the narrowing of arteries, deprives energy-demanding tissues of essential nutrients and oxygen. Additionally, increasing stiffness of blood vessels walls disrupts the finely tuned feedback mechanism that regulate blood pressure, leading to chronic hypertension. Hypertension, in turn, causes pressure damage to delicate tissues throughout the body, such as kidney, brain, and also it leads to accelerated aging and chronic dysfunction related to this. So, and the saying by Thomas Sydenham from 17th century, it is so many, it is 400 years ago. And he said, a man is as old as his arteries, and it remains as relevant today as it was then. And somehow people don't pay attention to this. They propose for rejuvenation, they propose genetic modification and injections of stem cells, etc., etc. While we have to stay focused on this idea, which is true, which was proven by centuries of the research, that we have to pay attention to our arteries and blood vessels also. Okay, so this is Thomas Sydenham, brilliant scientist of the past. Arteries in young healthy humans and other mammals stretch easily because they contain fibers of a protein called elastin. Elastin is produced only during the body development, however, it is slowly lost with aging while the blood vessels are getting stiffer. This is kind of miracle. Why in our childhood and the fetus development elastin fibers are produced, but then in adulthood they only degrade. So the extracellular matrix is a complex network of matrix proteins and metalloproteinases. It is the enzymes which regulate the composition of extracellular matrix, and glucosamine glucans that maintain structural integrity of the vasculature and contribute to its stiffness. Okay, so you can go more in science, and you see it is not so easy. That stiffness and of the extracellular matrix depends on many factors. And one of the primary mechanisms behind age-related vascular stiffening is alteration in extracellular matrix, which involves an increase in collagen content and decrease in elastin fiber content. Collagen fibers are 1,000 times stiffer than elastin fibers. Content of collagen limits the elasticity of arterial walls. Stiff arteries contribute to development of hypertension and significantly increase the risk of sudden arrhythmic death syndrome, stroke, myocardial infarction, and cognitive decline. It is again, you see, it is the main cause of aging, stiffening of arteries. So here schematically the structure of artery is presented. It has some kind of, we can say, layers, starting from endothelium layer, which is very thin layer on the inside of the arteries, and then we have layers of elastin and collagen and smooth muscle cells, etc., etc. So it is relatively complicated structure, but yet again, what is important, it is the ratio between elastin fibers and collagen fibers. Elastin provides flexibility and extensibility to the vessel wall. Aging leads to the degradation of elastin fibers by proteolytic enzymes such as matrix metalloproteinases, increasing the collagen to elastin ratio and vessel wall stiffness. In addition to increased elastin degradation and increased collagen deposition, there is also non-enzymatic glycation that induces collagen cross-linking by sugar molecules and increases vessel wall stiffness. Some genetic conditions such as Williams-Beuren syndrome and supravalvular aortic stenosis, okay, you can go and read this description. This is genetic conditions, quite rare, And children with these conditions don't live too long, maybe up to 15 years, and they die from all complications which are normal for humans, normal humans. I mean, that's hypertension and very quick increase of the stiffening of the body and skin, etc. So these genetic conditions lead to abnormally low levels of elastin in developing arteries. As a result, children with these syndromes have stiff, narrow arteries and hypertension. They develop hypertension. Like older adults, they are also at increased risk of sudden arrhythmic death syndrome and stroke. Okay, so what we have? So we have a number of some genetic conditions which result like very quick accelerated aging. So, but again, this is the main cause of aging: stiffening of extracellular matrix and especially vascular stiffness. Elastin fibers in the body are made of mixture of tropoelastin blocks cross-link via their lysine residues and fibrosis fibrillin. Both components are primarily made of amino acids such as glycine, valine, alanine, and proline. Other amino acids such as arginine, alanine, histidine, methionine, threonine, and tyrosine may also play a role in collagen elastin production, but maybe it is again not main. Main amino acids are glycine, valine, alanine, and proline. What is limiting it is glycine, availability of glycine for elastin production. So certain vitamins and microelements such as vitamin C, and vitamin A derivatives, vitamin B, vitamin E, vitamin K, copper, zinc, and coenzyme Q10 support collagen and elastin production. Some foods and components like cocoa, flavonols, garlic, beetroot, curcumin, and dill seeds show associations with improved arterial elasticity. You can go read the publication. Additionally, extracts, water extracts, so household berries, ginkgo biloba, gotu exhibit potential for reducing arterial stiffness. Okay, this is a picture represent scanned electron photos of aortic elastin from this old individual and young individual, 67 years and 6 years old. Okay, you see that elastin is degraded in the upper photos, and here it is very elastic and thin elastin fibers. Here it's a larger magnification. You see again, here it is young individual, here it is old individual. In old individuals already these elastin fibers are disrupted, destroyed, and so it is, our tissue and especially arterial walls are getting stiff. This stiffness of the skin is especially visible in older people because what is happening and aging and also diabetes, suffering from diabetes, it is high sugar content leads to broken collagen and elastin fibers. It is also so it is getting thinner, skin is getting thinner, and all these fibers are broken, and because of this many other conditions like oxidative stress and intoxication, the skin cannot get elastic again. Okay, this is how the elastin fibers are produced. So tropoelastin fibers, they are produced by the specialized cells, tropoelastin, but they have to be combined and have to be cross-linked to each other, and also these fibrils are important because they have some microfibril structure around to grow the elastin fibers. Addressing age-related vascular stiffening involves several strategies. So first, it is quite obvious, clearing senescent cells and reducing inflammatory signaling can help mitigate some of the dynamic dysfunction in the smooth muscle responsible for blood vessel contraction and relaxation. Finding ways to break persistent cross-links of the vascular extracellular matrix with advanced enzymes could also be beneficial, yet a significant challenge lies in restoring elastin content and its relationship with collagen in the extracellular matrix. Elastin is primarily produced during the development period of life, and its complex structure contributes to tissue elasticity. Rejuvenating the extracellular matrix will luckily restore a sophisticated control over cell population capable of producing and depositing elastin fibers, and which is an area of insufficient research have been conducted, because it is so complicated area of research, and also it is very time consuming to find out what we can do for elastin production, how we can keep our body elastic. Then it's again mostly money go to genetic research, which has no, in my opinion, it is wrong direction. So we have to go here, but it's, again, it is not getting enough attention and no money for this research. So what we have, this is senescent cells, and senescent cells produce some substances, pro-inflammatory substances, and what is happening, inflammation and changes in extracellular matrix. It's again the way of aging. Okay, here again we have cross links between collagen fibers, and you can go to this into details, click on this picture, you go to the publication about this, talking about this. But again, the idea is such that to destroy this cross-linked protein, cross-linked collagen fibers, to destroy them and replace by new ones. This is the idea, because cross-linking is increasing stiffness of the extracellular matrix and stiffness of our arteries. So again, you see the fibrils, collagen, they are cross-linked with lysine connections. This is again, this is how the elastic fibers get produced through this cross-linking. But we have also cross-linking of collagen fibers. What is important, we need some enzymes which will destroy this bonding, cross-linking, and then it can be replaced. But again, it is quite complicated area of research, so only few people go in this direction. Calcification of the vessel wall is another aspect of aging that reduces elasticity. This is already advanced stage. There is a direct correlation between aortic calcification and arterial stiffness in humans, certainly. Age-related calcinosis of arterial walls have been linked to increased oxidized low-density lipoprotein. Okay, this is again kind of speculations, because it is correlated, but it is not caused by accumulation of oxidized low density lipoprotein. So if we have accumulation of this oxidized low density protein, then it can be related to accumulation of calcium phosphate in arterial walls. But again, this is not caused. So, but again, it is unclear which process occurs first, and it is just a kind of not related process. Some speculate that calcinosis enhances adhesion of oxidized lipoprotein in arterial wall. Well, maybe again, but again, if we are talking about oxidized lipoprotein, we have to understand what it is, how we can reduce amount oxidized low density lipoprotein, or so-called bad cholesterol. And what advice you will find from medical professionals and medical dietitians, they are mostly wrong. I recommend you follow Paul Mason. Paul Mason is a physician who works with sportsmen, with this Olympic sportsman, and he is very, very brilliant researcher. He always demonstrates that we have to distinguish good cholesterol from bad cholesterol. Bad cholesterol, it is not cholesterol itself. Bad cholesterol, it is just replacement of the name oxidized low density lipoprotein. They call it bad cholesterol, but cholesterol itself is very, very necessary for us again, and how we can get it or improve our health. He explained a lot, and I mostly follow his advice, and so I share this opinion of him. Okay, then again, increased oxidative stress with agents stimulates vascular calcification by activating several signaling cascades, primarily due to decreased mitophagy and autophagy. Again, it is a relatively complicated chain of processes, so it is, you can say, yes, this accumulation of calcium may decrease mitophagy, but again, it is just several processes which are not related, but it is just there happening as a cascade of this degradation in our body. One studied pathway involves upregulation of bone morphogenetic proteins in response to oxidative stress, leading to increased vascular calcification. Again, a lot of ideas about this, a lot of speculations, but again, what is happening? You have stiffening of the arteries due to cross-linking of extracellular matrix with sugar molecules. Next step is oxidative stress, and oxidative stress eventually ignite further stiffening of blood vessels, and then vascular calcification goes. But oxidative stress, yes, you can think how to reduce oxidative stress, and this also may prevent your calcification of the blood vessels, but it is, again, this is, you cannot say that it is just you reduce oxidative stress and avoid calcification. It is not so easy. It is not so easy again, because you have to go into details. So calcification can go two ways: intimal calcification and calcification of the inner layer of the artery wall, and medial calcification inside the arterial wall. Okay, this or that. But these are details which are maybe not very important to develop strategy for to reverse aging. So what is happening? Oxidation of this low density lipoprotein. How it happens? If you have inside the low density lipoprotein, if you have polyunsaturated fatty acids from seed oils, they easily can be oxidized. Okay, then you have accumulation of this oxidized lipoproteins, and then further you have accumulation of these particles, including high density lipoproteins with oxidized, so they both can be oxidized, not only low protein density protein, but oxidized high density lipoprotein, also harmful. And again, what to do? You have to think it's about dietary interventions and avoid vegetable oils. At least this step should help. The vascular endothelium is the innermost monolayer of cells lining blood vessels. When healthy, it regulates vascular tone through a balance of vascular constriction and vascular dilation, the latter controlled by nitric oxide synthase activation, this enzyme, and release of nitric oxide from L-arginine. Okay, so again, the endothelium producing this enzyme, and then this enzyme works to produce nitric oxide from L-arginine. Reduced bioavailability of nitric oxide leads to endothelium dysfunction, or vice versa actually. So dysfunction of endothelium leads to reduced bioavailability of nitric oxide, resulting in impaired vasodilation, increased arterial stiffness. This dysfunction, along with decreased nitric oxide bioavailability, occurs with aging, leading to pro-inflammatory vasoconstrictive state and subsequently increased vascular fibrosis and arterial stiffness. Endothelium dysfunction also increases oxidative stress by promoting the production of superoxide, so reactive oxygen species, which damages blood vessels and alters hemodynamics. Okay, this is again, people not exactly understand the chain, what is the causing the stiffening of blood vessels, so it is a lot of speculations. You can go into this research and maybe come to your own conclusions, which may be different from what I propose. So normal arteries, again, they are able to dilate if blood flow is increasing, and the endothelium cells produce this enzyme, and the enzyme reacts with L-arginine to produce nitric oxide. But it is even it is necessary also when there is no need for blood supply. So it is, and you have to redistribute blood flow in your body. Then you will have vasoconstriction. So the muscle cells, they reduce the lumen of the arteries. Recent studies suggest that autophagy decreases in cells by aging endothelium of the aging endothelium. So okay, autophagy is going in all cells, but in particular, autophagy decreases in cells of the endothelium, and further increasing oxidative stress, because accumulation of some waste products inside this endothelium cells, it is no good at all. This was confirmed by using pro-autophagy treatment with spermidine. Supplementation with spermidine reverses large artery stiffening, restores nitric oxide mediated endothelium function, and reduces oxidative stress in arteries of old mice. In humans, high levels of dietary spermidine were correlated with reduced blood pressure. Yes, so good dietary sources of spermidine are cheddar cheese, so dairy product actually, and mushrooms. However, another long-term clinical trial in humans showed no benefit of spermidine over placebo on cognition and biomarkers of aging in older adults. Okay, I believe that this negative result is related that the trial was not long enough, so you have to use this spermidine for longer, and again, if you don't see benefits on cognition, it is just again because you already cannot reverse stiffening of the blood vessel. So it is you can slow down but not reverse. The spermidine, I mean, eating mushrooms is, well, I believe it's very healthy. So spermidine is nitric containing substance. Okay, this mushrooms. Yeah, I recommend cheddar. Yeah, very good, and all dairy products. Vascular smooth muscle cells have been identified as a significant contributor to age-related increases in arterial stiffness. The stiffness of these vessels, they also stiffening because a membrane of these cells can get stiffer. Why? Because again, I don't go into details, but it is if you have phytosterols in your food, then the membrane of this vascular smooth muscle cells is getting stiffer, and it is also contributes to stiffness of these muscle cells. Okay, then stiffness of the vascular smooth muscle cells is influenced by their relationship with endothelium cells, which regulate vascular tone primarily through enzyme nitric oxide synthase that catalyzes the oxidation of L-arginine and release of nitric oxide. Nitric oxide reduces the active tone of these muscular cells, counteracting the increased wall shear stress associated with aging and high blood pressure. However, aging also results in a decrease in number of these muscular cells within the vascular wall due to reduced cell proliferation. This decrease is enhanced by various mechanisms, notably chronic inflammation and calcification, which increase apoptosis of the vascular smooth muscle cells. Apoptosis is the death of the cells. In humans, the loss of these muscular cells with aging is replaced by collagen fibers in the arterial wall media, leading to increased vascular stiffness. Okay, you see how it's not easy. Not easy because they are interlinked process happening over time. So here structure of the arteries, this we have this endothelium layer, we have this muscular cells, muscle cells which regulate blood flow through the blood vessel, and okay, this blood go. Okay, so you can go to the references of information to scientific publications, and you can go and you can make your own research. Maybe you have the opinion different from mine. It is again, it is up to you. I am not insisting. This presentation only for information, to inform you about what is happening. It is this not very easy process. It's very interlinked, it's a very complicated process, and I don't give any medical advice in here because I'm just talking about processes, what is causing of the aging, and again, but how to reverse it, it is another question. Here I talk only what is happening over time in our blood vessels, and then you can conclude how to reverse this process or maybe at least slow down. Okay, then as always, you can support my research because again I was talking that in this direction, in directions to reduce stiffening of the extracellular matrix and arterial walls. Now almost nobody works. All money go in wrong direction, in my opinion. Not to me, not to some companies. There are some few other people who support this idea of the stiffening of extracellular matrix and stiffening of the blood vessels, that this is the core cause of the root cause of the old aging. And but again, I don't have any support. At least what you can do, you can press like and bell button, subscribe to my channel, share this video with your friends and family. And of course, while I do all this research for myself to extend my longevity to infinity or maybe 2000 years, to 1000 years, it's again, if you want to join this project, okay, you can go to the links in the description to this video to my Telegram channel and communicate with me, and we can talk about, you can decide yourself how much you can participate in this research or how you can support additionally. But at least what you can do, it will take nothing from you if you will press like and bell button, subscribe, and make some comments. Normally I ask, if you ask questions, normally I reply on the questions normally. But again, I don't give medical advice in here because again, it is not allowed. It is what I do. It is not. It is only for informational purposes. If you participate in my project, then we can discuss, we can talk about this, maybe decide what self-experimentation to do under supervision of some medical professionals. Again, it is not easy, but as I said, unfortunately, not many people participate in this research, or mostly money go to wrong direction, to genetic modification, to stem cells injections, and some treatments which are like replacing of your blood plasma in old people by replacing blood plasma from young donors, etc., etc. So quite complicated and very expensive procedures. Also, what I completely opposite to this, because it's very expensive. The estimation of your biological age with so epigenetic clock, which was proposed and very much popular, but it is few thousand American dollars, and then measurements with this clock is giving very strange results. Like in few weeks, in 2 weeks, you can reduce your estimated biological age like 10 years. Or if you inject stem cells in your body, in your plasma, then you'll get rejuvenation like 15-20 years, but without any change in your appearance, without any change in your metabolism. And this is also short-living data. In time, all the stem cells will just die out, or will be expelled, will not participate much in the rejuvenation of your body. I don't say that it is absolutely useless, but it is expensive, and monitoring of your health can be done much easier, much cheaper. Also, interventions which I propose are affordable for almost anyone. I propose to follow nature and use only natural way for rejuvenation and radical lifespan extension, different from people who want money, who want you pay millions and millions. There are some people pay a few millions American dollars per year for treatments, and I don't see any improvement in their health. And quite opposite, there are some relatively cheap interventions and supplements, and I see some people use it. I started to use it relatively not long ago, and I see improvement in my muscular health and total health and blood pressure. But some people use it for 20 years. Yeah, like Tom Cruise, for example, a good example. Tom Cruise started to use some procedures which are very helpful. Not again, you can make more, but he using at least some correct procedures, some, and relatively cheap. Not very cheap, because if you go officially through these treatments, you have to pay in California 5,000 American dollars for the 4-6 weeks of this treatment, and you have to do this treatment a few times a year. So it is not very cheap, but maybe affordable for some Hollywood people. What I propose is much cheaper. I cannot afford to go to the same like Tom Cruise, but at least again I see that it works. It works for me. But as I started to do it not long ago, I need maybe 20 years to see much improvement. But Tom Cruise, good demonstration that it is possible to decelerate aging and to stay relatively active, relatively young in older age. I'm 67 for now, but quite in good health. Okay, have a good, wonderful day. Ciao, ciao.